Okay, so let's move on. We have P, that is a strain in B64. If we decode it with a decoder, we see that the header, if we make a file, it says that it could be a ting image. But if we see any editor that we can talk to and we can open it, we see nothing. So we leave it aside and we'll see whether we can do anything with this. And we follow this file that has been written, and it seems that it has more data. PS1 is the extension of PowerShell files, and what we can see here is a PowerShell that is in one line, and at the beginning we see a combination of characters. If we solve just the ID 1 and 13, we see that they are IE, so it's IEX. So it's going to execute anything that could solve the previous thing. As we don't want it to be executed right now, and as we want to see what this does, we can change the IEX. It's like eval of other languages. We can replace it by a write, and we redirect whatever we've got. Well, if you see the string, if number is 64 with transformations, it takes other things, etc. So we won't stop here because we want to keep on moving, and we take it to the file. We would do it with this line that you can see here. We modified, we change it for write, we redirect it to a file, we find another script that has the same to execute, so we do exactly the same, right, and we take the file out. And here we have something that's readable. Manufacturer, mode, variables, etc. A function that is called hackerman. So we have a PowerShell code that can be seen. We can see what it's going to happen with this. So, what does the script have? Apart from reading it clearly, it has a check of the flags, purification flags. It's another debug measure. So if it matches with this, the script would be done. It wouldn't be executed. On the other hand, the good thing is that we have, well, this text, plain text. So we can open a PowerShell, we can apply changes on the script. So here we do not have to patch, we don't have to include breakpoints, we don't have to make changes. We have the script, we can delete this line and keep on moving. So after this, it checks that we have the registry code that were the 6 characters that the other binary had written down. It checks that this exists, and if it doesn't, it would equally be over, and it stores it in a variable. And it checks that P file exists to the one that had written the binary, and we thought that it was an image. Okay, so this value is retrieved, and as we see, what we had in the registry was the 6-second characters. We knew the first ones, but it retrieves the 6-second ones of what we had typed in the previous binary. It retrieves it and it stores them in the variable data1. After this, it creates a new variable s, and it makes a loop, a for loop here, where it applies an XOR with 1, a normal XOR, to every character of this variable. And this is what happens with the hackerman function that we saw as defined on the top. This function checks this string after applying the XOR. So the first thing it does is that it stores in a hack variable the result of the character 5. Well, this is the last one. So this character minus 2 or the full representation of the character, and it should match the PowerShell version that we have in the device that has been calculated at the very beginning.
Yes, okay, well, for the time being, no idea about it, because we don't know about the values, so we cannot say which version or release of PowerPoint it means. But we see here a comparison per character here, we see, and the second character, 1, is compared to see if it looks like, if it is equal to the result of having the XOR 88 and 89, comparing both. So we can now, for instance, copy this. We can have this in our PowerShell, and to see what happens, if we execute the first one, we will get 1, the second character will be 1. Then, if we then, for instance, in the second one, we'll get 46, 45. From here we get a 3. Then we check with the W. That means the first character should be W, of course. And then we have here, for instance, the same thing, as I said. The thing is, it depends on the previous ones, but as we have got to them, we have got a 2 here out of them. Then this one, the 3 with 5 that we had calculated before. From here we get, we'll see a 1, and the last one here, the third character is done differently, is comparing digits. It is like we take figure number 4, the digit number 4, and 13th, yes. And then out of this we get a 0 from this digit, and then we get the string after applying the XOR, and then we get a file from this with the name that's W and this path, and the function will say true. If we were in this, it will be false. So we have the same operation before. Is 3 minus 0 plus 2 is 5. What we have to say is that our version will be release 5. That means that it is to have an array, and to define this and to work with this array has to be done only with this version, this release only. Then yes, okay, we have the string, and I don't know, we have it's W10 to 3, as it is reversible. To know what happens in the previous binary, we do this, we define, we have a new variable, and we apply the same operation to it, and then we perform the same thing, and what we had written it will be V01032. Then we know that it should be Atari space this. Then we're getting information about it, and then last but not least, after this, after Hackerman is giving us a correct result, saying true, we, after the XOR, we just we write the value after XOR in this doc file. It is W space doc, D-O-R-C, with the content of the variable. Then we calculate the character as a result of what is here. Then what is applied is 4056 is minus that amount to each value of the array, and it is written in this AXSL file in ASCII format, and we write it according to this technique, WMIC, which allows us to pass this format which is a file XML. But then in the XML code, we can add the JavaScript code. This is what we do. This is a way of having a bypass. It's a technique of bypass. If by any chance, as this is by sign and proper, there is a way to skip it, to jump, to have a bypass. The technique was created a few months ago. And then we have a new file, a.xls. It was a header XML. In the end, there was a tag defined here that is the language JavaScript, and the code has lots of strings here. As we see, it's 64 base, and there are things we have to clear. If we look for the strings with the codes we have here, then it is there are references that could be a .NET reference to JavaScript. So of course we might have another binary in between, and then in JavaScript is similar to the other one, but the implementation is by Microsoft, and then the end is as you see here, it is we can use it to delete this. We have this possibility of using the dot, and it is here the 64 auto stream. It is coded in 64 base codes. There are versions here that are, as we see here, we have a semicolon here, and they use the variable that is the array defined there, up there with a string. After that, there is a code which is the main code. It is as such, it is not a function, it is a one as such, and it is what works with the upper part of it. And then there is an object here. If on top we look about this technique, there is a serialized object there, serial object that's been hard-coded on top. To render this more difficult, they had created this, adding up several 64 base chains, strings, and there are this to other arrays. But if you know how it works, you get the MZ value, and then in the end, out of this enormous jet, you want to have to know what it is, to know what it is, and to do it, not to have to get attached. Then you use the debuggers, one of the debuggers I mentioned before, the ones I had on my machine, and have this debugger here. That is a debugger. You could have a breakpoint, and you could consult the value of the variable, having established concatenation, or simply you can comment on the code, and you can have the you can print on screen. So you can have here, you can have W script to play, to execute, and you see down here the variable on screen. It's simple. Then with this, we retrieve this. We have 64 decode, and if we take it, this is not ready to be executed directly, but it is possible to analyze the code here. So with this editor AXLS, we go and we load the program on DNS Spy that allows us to see, because it is .NET, it is possible to have access to the code, to the source code, original source code. It's not a representation, but it is the source code as such. What do we see here? The program that's been executed from the hard disk memory. The program, the software is checking that the date where it was executed, it is the 1st of January 2019. And to skip this, then you could have we could put your device tuned to that date. As it is not executable, you cannot use the debugger from NetSpy, but we can use a new binary, create a new binary, and to use this binary, or even when we write this, we could delete this condition, and we can jump onto the next one. If it is the expected date value, you go to the main, and in this case, there is a request to this domain of internet domain. Having this request, the site will give back, and it said on purpose 500. The message is 500. URL sends the 500, and if you have a GET response, what you get is an exception. What is it? It is a try-catch, and the catch will get the exception, and it goes to the other thing, which is program, C program. It is not what the software expects to do. And then what is it? Then they check. There is a P. The P was from before, from the first binary. You remember the header of the image that was base 64. So it checks P and doc, so created by the PowerShell file with the variable having applied export of what has been included in the program, and to the content, to the W10, they have as an appendix the string shark01. And then there is a variable attributed, and the P and dog files are deleted. And there is an anti-bug checking based on time. Then the seconds elapsed. If there are less than 1,000 seconds, the program is not doing what we're wanting this to have. It is an anti-debug measure. As we're going to write a new program, we delete this line and we'll let it execute. Then the string calculated with this value and the shark01 goes to a deciphering process in AES, and the P value is used using the dark key. P is going to be read, is going to be deciphered, and P is going to be deciphered, and is going to be written in W. Then we have W now. If we have a file, we see its data. We look at the entropy, high entropy. That means that it is a file, surely, that is ciphered. It's ciphered file, and then we have to remember the hint we got at the beginning. Think about true ciphering. If we look for true ciphering, here the size of a binary is 512,000 bytes. That's striking, that is 512,000. It's striking to be precisely that size, that amount. And then you see here and you get mad trying to look for what it could be. You say, well, does it mean something to you? You ask your friends and co-workers, and having looked around, you get to this conclusion. The proper ciphering means true crypt, perhaps. If we look for true crypt containers, the contents are, in general, in true crypt, those are 512 modules. 512 modules. It seems that what we have is a container of true crypt. But to retrieve this and to see the content, we will need a password. And then, to have a password, the first thing we do is we give a try with whatever we have from before. And then you see that it is not helping us, and you look to do it in a tough mode. So let's see if I am lucky enough. We use tools like jump, but we have to have the hashes from the container. So there is a script, and the references are here. You have it. It is reading the container from TrueCrypt, and you'll get hashes in a format that is understood. properly, and then by John. And what happens there is that I have executed this, I have used the RootedCON, and I let it executed. I let it to be executed. And what happened with hashcat? In TrueCrypt, you have two modes, the normal mode and the hidden mode. And then the way to calculate hashes well, it's such that you have to skip the first bytes, the 65,536 first ones, and then for the next ciphering, you start with the 6211, which is this one, and then the other one go to that hidden, and then the normal one, and you run this, and you run RootedCON. And for those modes, there is a password that's valid, and it's different per each of those. And at first you have the normal mode. In hashcat, it is what you will do. Then you get what's up there here, and then you get the, I say, you say, well, what happens to you? It drives you mad, you look at this, and you say, well, that's the end of it. Let's call it today. But if you've done it with the John and you have got everything and you have the two passwords, you say, good, okay. I try with hidden, and I try and I use the other password, and it is okay, fantastic. But it is not the end of it. Then we have a file, a flag file, that it takes 48 bytes. And then you say, let's hope it is ASCII. But no, we were not lucky enough. So we have here a file with the header you see. File is telling us that it is a ciphered file with an open SSL, and to which it's been applied, so we get no image. Now it's okay. Thank you. Perfect. Thank you very much. Then we're about to finish our presentation. So we have this. Same thing. We will try under the conditions we had before. We run the RootedCON again, and then we had this program, small program with OpenSSL. We have here lots of ciphering types, bunch of them, and per cipher mode you can give a type of digest. If we want to give a try, if we want to try with several attacks, we can try each type of ciphering and each type of digest. There is no other hint in the challenge. And even though I don't know if the other colleagues having solved this have found an easier mode, but I couldn't. I would say no, and then we have to try this, and little by little, perhaps you try those other ones you have, and well, you can try, for instance, with the typical ones, or with the full digest first, try to apply some intelligence to counteract the attack, but in this case, this is to do it roughly, to do it against the file and with a brute, it's an OpenSSL, and it is a way to have this force and mode using the chaser. I used this chaser, figures, capital letters, small letters, the characters I got from other passwords, to give a try with this, to try this. We have here, it will be a string of characters from 4 up to 7, that's length and range. Then you ask your co-workers to let you use their devices, and you use servers, and you try to split it and to work together. And here with the brute force, is printing possible passwords based on the fact that 90% of the string of characters of what has been deciphered are printable ones. So I look at this, I read the word candidate, it's what they use, and I printed this on screen using the ciphering mode, which is candidate and the digest used. For that, with what I get from here, I retrieve this and I put this into this dictionary, where I try to execute this, because you do not take the deciphering directly. They say it is an eligible candidate, that's it. And then you have to execute this with OpenSSL with a step, and I put it in this flag file, where you have the algorithm used for ciphering and the jump and the password. And then I can take this per type of candidate I can get here, and I have lots of files. And then what I check afterwards is that everything that comes out of this, 100% of characters, should be printable characters of the string. And if I let it run, if I let it execute, then you end up by finding the password. It was 6 characters, 6 character long, and 4 of those, the first were figures and the same figure, because you use a bit of intelligence there. So you have the flag, and you introduce this. It is the flag and the MD5 of this flag, and it tells us that we are great, that we were very good. We're amazing, that's what I wanted to say, we're good at it. Questions? Questions, comments? I don't know. It is understandable that you've lost track, but I will give you the slides. I have my blog, and you can read my slides, and you can do it directly. It's the only way to control this. And those who haven't seen this before, I would recommend you to start from bottom up, from the basic. I think the first crack is easier, and I wish you luck and success with the challenges, and thank you very much.